Okay, I'm racking my brains to think what did I write this Sam's referring to? Because people are always asking me, what is a math circle? And I always feel like I have to start from scratch in thinking about it. So part of the point of this panel is sort of it's sort of an operational definition of a math circle. And not what a math circle is, but what a math circle does and how it does it. And I think let's just look around for about 5 minutes each talking about who you are, what your math circle, who it serves, who runs it, and so on. Just briefly, and I'll go last. Okay? So this gentleman go first.
Do I have to? Okay. I don't want to step on toes of anybody, especially Tatiana, who helped start a lot of the math circle programs that I'm involved with. So I'll try to talk about the ones that don't overlap with Tatiana. Oh, I'm Joshua Zucker. I live in the San Francisco Bay Area, and I'm a freelance math teacher, so I teach at lots of local math circles and online classes and things like that. So the math circle that I wanted to, or the model of math circle that I wanted to talk about is one that started in San Francisco about 6 years ago. Brandy has the t-shirt on right there. And it's spread to Oakland in the East Bay. And essentially after we'd been doing math circles in the Bay Area for about 5 or 6 years, we realized that we were really attracting people who were needy in the sense of their schools couldn't provide the math that they needed. And that's a good audience to serve. But there's a different category of kids who are needy of mathematics. And that category of kids tends to have parents who are less involved. So the model we've been using, where parents bring kids to math circles after school in the evenings, on the weekends, just wasn't reaching that population of kids who were interested in math, but who went to schools that really had very little math to offer. And so the model that we started in San Francisco and Oakland is to have teachers bring the kids immediately after school to the circle instead of depending on the parents to be that connection. And the teachers can then recommend kids who are interested in math, which is really the only prerequisite that we assume. And that way we can get the kids in who otherwise wouldn't be touched by math circles. And we also have the added advantage of, since the teachers are bringing them, at the same time we can also do a session for the teachers. And so we can show the teachers a little bit about what mathematical problem solving is like, which for a lot of the teachers is something that they've never really seen before either. So that's basically the strategy, and it seems to work fairly well. But still, even once we were doing that, there were still pretty big audiences that we weren't reaching. Schools that weren't represented, kids that just wouldn't come even if the teachers tried to drag them. And so we moved on from that to actually bringing the math circle to the individual schools and starting up programs in collaboration with the teachers at the schools. So the model there, instead of having a teacher's math circle session and student math circle sessions happening at the same time, is there's just one big group. The teachers come, they're like teaching assistants for the math circle. And the math circle leader comes in, and a bunch of kids who are already at the school, on the campus, come right after school to the math circle, and that's definitely helped reach some much bigger numbers there. And some of those programs have gotten big enough that kids from neighboring schools start to come and join in on the fun instead of it being just the kids at the one school where the circle is posted. So I think that's enough for me for now, and I can talk about other kinds of math circles if there's something that's still left out after we get to the end of the table.
And this is his sister with the same shirt.
It's not the same shirt, though. Not a different edition.
Different rotation,
Yeah.
orientation.
Oh, tricky.
You have the first edition. I have the second edition.
Yeah.
Okay.
My name's Amanda, and I'm the director of Riverbend Community Math Center in Indiana, South Bend, Indiana. And we've been, this is, we're coming up on 5 years that we've been doing this. My husband and I started this center because we grew up in South Bend area, and we wanted to go home and bring our love for mathematics to other people in our community. So we didn't know, when we started, we didn't know what it was that we were going to be doing exactly. Our mission is very broad. It's to improve access to math education for everybody to meet sort of the mathematical needs of our entire community. And so that means working with adults who want careers in building trades and need math to be able to pass the test to get into the apprenticeship programs for carpenters and electricians and engineering. And it means working in schools with teachers, and it means having enrichment programs for kids, and it means participating in community festivals and making sure that the extravaganza event has lots of math. We do a math trail where the kids go from store to store, and the vendors ask them different questions, and the parents are wandering up and down the streets phoning other people saying, "Got this question, not sure." So we try to make sure that lots of math is happening. We do a couple math circles that are more traditional, but those at the moment are small. Our bigger programs are math studio programs where we go to the Boys and Girls Club and dump out a bucket of polydrons and have them start exploring phase vectors of polyhedra and discovering platonic solids and writing little notes and that kind of thing. And our Math and Technology Academy program, which meets two times during the week and then on Sunday afternoons. And that's part tutoring program. Some of the kids come for math help, and but then we have 2 stations of math enrichment, so they learn how to program internal logo or do other kinds of math enrichment things. We do a lot of mathematical origami as a way of getting people to learn that they can't, that if they work systematically at something, they can achieve interesting things that boost their confidence. And then we also have more traditional sort of math circle style activities as well. Most of our work is actually in the schools, though, so we do a lot of going into classrooms and demonstrating.
I'm Tito Andrescu, and I teach at the University of Texas at Dallas. I run the Metroplex Math Circle at UTD with the support of the university and some parents, volunteers. And David Cordero is here as an example of an extremely enthusiastic parent who is doing a lot for the circle, maintaining a very good website with all kinds of information. And maybe you'll have a chance to talk about it in the sessions to come. This circle started in 2006, and again, the university has been very supportive. I went to the administration and said, you invested quite a bit of money into chess. UTD used to be the national champion for many years and still does very well. And I said, with the same amount of money, you can get very much visibility and do something for the community. And to my surprise, they were very supportive, as I said, and we are able to invite speakers, pay their way, and a small stipend. And there are people in this room who have been lecturers. One is to my right, Tatiana Shubin, and Rizvan Jelka, my good friend and co-author, has been at the circle too. And who else? And Harold Reiter, absolutely. He has been more than once, and we expect him to come back. And I invite other people in this room, if they are willing to share their experience with us, we'd be willing to, again, cover their expenses. And also, it's a good experience for them to come and visit our center. We started primarily with middle school and high school students and had 2 levels of instruction. Our circles are Saturdays from 2 to 4 p.m. while the university is in session. And to my surprise, the population of students became younger and younger and younger. So now we have 1 level, but I'd like to say that these kids are very smart and advanced in mathematics. So I hope I'll have more chance to describe various aspects of the circle when my turn comes back. not gonna keep the floor more.
Well, I'm Tatiana Shubin, and I've been running one of the two almost oldest math circles in this country. The oldest, as far as we know, is one in Boston. But the Kaplans started their circle maybe 3 or 2 years before we were in the Bay Area. And in the Bay Area, the idea actually belonged to Zvezda Stankova. And she was, at the time, she was at MSRI, postdoc at MSRI. And people in MSRI, Hugo Rosset and David Eisenbach, who were director and deputy director at the time, they were discussing this sort of state of math education in this country, and they were trying to figure out how to improve that. And Hugo had that idea that, well, they had a bunch of these young, talented mathematicians at the time, and stationed, they were fellows in MSRI. So Hugo sent an email to all these fellows asking for ideas. And 10 minutes later, Zvezda knocked on their door, and she said, well, math circle is a nice thing to start. And it all started, it happened in 1997, about April of 1997. And they started talking about it, and they started inviting people from various places. And in November of 1998, our two circles started within 1 day of one another. Berkeley Math Circle and San Jose Math Circle. And both of these two circles have been running ever since. Well, my circle actually runs itself. We started in the beginning. We tried to advertise it. We tried to send flyers and talk to teachers around in the Bay Area. And in the first year, we had 7 students coming to our circle. And it's a huge metropolitan area. And we were really trying to reach all the teachers and all the schools, and out of all that effort, 7 students materialized. And so it was kind of, touch and go. We didn't think that it would survive. Well, next year we had like 10 kids, and we continued trying to advertise it wide and fast. Guess what? Now we do not. We do not advertise it at all. We have between 20 and 30 students every week, and that's the top for us. We don't have room to accommodate more than that. So this is why I'm saying that it runs itself. Well, of course, we need to find speakers for every week. We meet on Wednesdays. We have always been meeting on Wednesdays from 7 to 9 p.m. Official. Unofficial, it's very hard to keep them out of it. They want to stay longer and they want to do more mathematics. We have speakers coming and giving talks, and whereas they are not related. The talks are not related, so we don't have a coherent schedule, but people actually like it that way. People say that the students get exposed to mathematics that otherwise they would probably see only when they become grad students in mathematics. Well, last week the topic was Gaussian integers, for example. And the majority of our students are 7 and 8 graders. We have always few younger kids and sometimes a few older kids, but the majority are 7 and 8 graders. One part of our circle that is probably not very typical is that approximately, we meet every week, except that approximately once a month, instead of our regular meeting, we have a bigger event called Bay Area Mathematical Adventures, BAMA, and we invite remarkable mathematicians, like, well, they are remarkable. We have John H. Conway, one of our speakers, Vladimir Arnold, another of our speakers, Lord Grant came more than once, and well, the list is very, very impressive. And so these people come and give a talk, and we always tell them that what we want them to really expose kids to real mathematics, bring them to the frontiers of mathematics, and they manage to do that. And our kids manage to argue with them when they find errors in what they're saying, and they are very, very much involved in all that. too. Why not we run a circle for middle school teachers? And we started with, that was the beginning of middle school teacher circles, which is a slightly different model from what Josh described. The circles that we run for teachers are for teachers' enjoyment. All our middle school teachers always tell us, in the beginning, they ask, how do we bring it to our classroom? What is the connection with our classroom? And it takes a while to convince them that, look, it's for you. It's not for your classroom. It's not for your kids. It's for you to enjoy, to get back to the point where you enjoy mathematics. You recall why you decided to be math teachers. And, I'm running past my time, sorry.
We'll get back to that.
So we started the teacher circle in 2006 at the same time when that other model was done.
My name is Shwan Ma, and I'm from Indianapolis, Indiana. So if any one of you plan to attend the national conference, NCTM this year, make sure that connect with me, so I'll be a good hostess in our town. I think sitting with the panel, I realized my program is probably the longest all. We started last fall, actually, so this is like a 6 month. I feel like today is my midterm exam. I'm telling you how it's running. It really got started with, again, conversation with like-minded people. Amanda, she's sitting here. I call her the godmother of this math circle program. So she really gave a lot of advice and encouragement and connecting with David, sitting back there quickly. So he gave the dosage of financial support that we needed to get it kick-started. Again, a lot of wonderful resources. The Circle in the Box, it's printed out and sitting at my work desk, in my home office, and my bedroom table. So I rely on that after kind of day. The circle that I run is really based on local needs. I guess our circle is the first in Indianapolis. I work with a local charter school because some of the volunteer work I have done in the past, so I got to know the school principal. And they mentioned to me their math teacher is actually an education major. And he is not the most motivated teacher. He wanted it, he signed up on the Teaching for America, that program, so he thought he has to fulfill that contract by teaching that school. And typically, I don't think, I would think of charter school students as the primary audience for a math enrichment program, but I decided to give it a try. So last fall, we ran quickly to spend the money. They would give me that challenge before Christmas, so we ran 6 sessions. I went there. We focused on one kind of a theme. We did the President Garfield's visual proof of Pythagorean theorem. It's a mouthful to say, but basically we started with just a piece of paper as a rectangle and guided them with several intermittent steps of challenges. How to divide it in half. Somehow I guided them into, do a diagonal line to give it 2 right triangles. And then compose that into a trapezoid. And then using the area of the 3 right triangles and using basic algebra to derive actually c squared equals a squared plus b squared. So that's the session we ran, and for the, I'm sorry, I forgot to say these are the 7th graders. They had to pass some kind of test to be eligible to be attending those sessions. So it was very well received, just the enthusiasm from the kids, and then from the integers, the sum of the integers, and hopefully derive into the mathematical induction piece. Now I have both 7th and 8th graders. Myself, actually I work full-time. I've been working full-time for a textbook publishing company. And in my full-time job, I work a lot with high ed universities and focusing on developing math curriculum for developmental math, And in working with that group, over the years, I just realized there's a lot of gaps between the secondary education to the high ed. And for example, the same topic, fraction, has to hit the kid for 3 times by the time they get to developmental math, and I just didn't think it was making sense. And just the culture of students hating math and dragging their feet to go into math class. So that spurred that kind of idea, because myself, I do have formal training in science, but I'm not by any means a mathematician or a math researcher, but I'm a math hobbyist. I like to do puzzles and, Martin Gardner's book thing. So I thought, well, so to say the least, I want to communicate that enthusiasm to the younger kids before there are 2 conditions. So that was the motivation. Okay, done.
We're going to talk more about what, I'll tell you about myself. My name is Mark Sorrell. As of this fall, so I'm doing something, although I've been doing math circles for about 300 years. And the reason I'm doing is about as new as I started in the fall at the Center for Mathematical Talent at the Courant Institute of Mathematical Sciences, which was funded by the Sloan Foundation to do a variety of outreach programs. I won't talk about all of them. I'll talk about math circles, which I see as one of the driving engines behind the work. We started various models. We started 5 math circles in the fall. Between the fall and now. The one model that hasn't been mentioned so far is, and I'm not sure if this is unique to New York or to my work or whatever, a model where you go into the school during the school day and work with the teacher in a class that's convened anyway, in math circle style. And the reason I started doing this is because this is something that you will all recognize nationwide, is that with the recent sweep of testing, recent being the last 10 years and No Child Left Behind, has essentially killed off gifted programs from coast to coast. And the reason is, and I can give you chapter and verse about this, if you make the goal of education to get everybody to a certain level, then as soon as they get above that level, they're no longer your responsibility. And people feel this in their bones, although it won't come out of their mouths. So when you go into schools frequently, and I want to hear what other people have to say. By the way, that's my real motive for doing this, for running this panel, is to hear some solutions and some sides to the problems that I have. So I'm hoping that you'll share them. So when you talk to people in the schools, they have their hands full getting the kids to pass the test. The other population that this leaves behind, despite the name of the law, is a very low population who have no hope of passing the test. But mostly those kids have identified conditions that they're protected by certain laws. They mostly, even if they have to struggle to get what they need, there are mechanisms and institutions behind them. For the kid who's passed the test, there's nothing. And that's the mandate of the Center for Mathematical Talent. So if you come into the school, I found that frequently teachers found it a terrible burden. They're under incredible pressure to get these bubble kids. Have you heard that term? The kids who are just below the test, to get them just above the test, because that's the biggest bang for your buck. They're in such pressure to do that, that anything to do after school or even during school for the kid who's already passed the test is something extra for them. It's not, they don't perceive it as their job description. So what I started doing was finding those kids who did pass the test, and very typically they are put into a special class or end up in a certain class in the schools. And I go in and talk with the teachers students, and either I go in or have graduate students go in, and work with them on math that these kids would not otherwise get. Not remedial math, not just the next year's mathematics, not something from the textbook, all these things that math circles are not. But things that we know how to do, that math hobbyists or the people on the panel know how to do, that these kids would never see otherwise. And the other thing that I'll say, and then I'll shut up, is that I don't choose these kids. These kids are there for whatever reason. So in one high school in the Lower East Side, these kids have passed the basic minimal requirements in arithmetic and algebra. And otherwise, there are 5 kids in the room, and I don't know what they know or what they can do. And you just have to work on what on whatever you've got. So it's a little bit challenging, but very, extremely varied. There's another group I work with, this is interesting. These are kids who they have decided will not pass the test for another 2 years. And you can see why. These are 4th and 5th graders who are way behind. And I come in 1 day a week and I do math with them in ways that they've never seen. If you have taught remedial mathematics, you know that the cardinal sin of doing anything remedial is to do the same thing that didn't work the first time. If you hit them over the head once and they don't go down, they're not going to go down again if you hit them over the head. So you have to try new things. And what I find is that some of the kids who I've seen who test the lowest in these tests are the brightest in some of these tests. Get these things very quickly, and all of a sudden are the teacher in the class. And my comment is, what does that say about the test we're trying to give the kids? All right. So I've been making some notes. Yeah, go ahead.
Good. I run a similar program in the Dallas area, more precisely in Plano, called Math Rocks. It's for the elementary and middle school students, and it will run into high school. These kids that were identified as being gifted, at least 2 standard deviations on a standardized test, the math, are selected and pulled out from their classrooms for mathematics only, and they take this rich curriculum, which is by no means, as you said, next year's math. It's the kind of mathematics these kids deserve, and unfortunately, it's not present in the mainstream curriculum. So I can tell you more if you are interested about this. There are 11 schools now, and about 250 kids involved. I meet with the teachers every month for a day, and we go over the materials that I designed. And they got comfortable with these materials. Of course, they asked questions, and some were not very comfortable with this kind of problem solving. But now they are transformed. With one exception, I could see big progress. They realized in these 3 years we had a program. It starts in 4th and 5th grade. It's a common thing. It goes for 3 years. There are some exceptional 3rd graders allowed into the program, so they do the same mathematics that school year, and they move on into algebra in 7th grade, and they do geometry in 8th grade, and pre-calculus and 11th grade. And the plan is for the last 3 years in high school, they will be enrolled at UTD, and they will take university classes like the calculus, differential equations, all these courses.
So I have a question, not just for you, for the whole panel. And I told you that I'm feeding off this panel from my work. What are the motivations for the various people? Kids is easy to motivate. You tell them to do it, or you give them something on your own and they want to do it. What motivates the schools to provide these subjects?
I can answer this.
Well, let's go around.
Okay.
I guess in the case of the school that I work at the most, it's one teacher heard about it, came and checked it out. We run a summer program for teachers. He came to the summer program and liked what he saw, and then worked to first bring his kids to us and then later bring us to his school. So it was really the summer teacher circle programs that was big in, I think.
And it was sort of an individual who
I guess there's also been some at the other schools in San Francisco of connection between the university and the math ed program and the teachers and so there's lots of different networking going on. But the one that's easiest to cause on purpose, I guess, is the summer programs.
I haven't seen the difficulties with motivating school districts or teachers to try math circle techniques. They are all very hungry for these approaches, actually, and I work with all the schools in the South Bend district and all the ones in the Mishawaka district, which are next door. There are different mandates that they have from the state, so that the new national core standards, the math standards, I don't know how many people have had a chance to look at those. And there's always things to pick at and things that are unfortunate, and there are definitely unfortunate things about how it's being tested in some cases. But to be fair, the tests, the assessments, cannot be passed unless kids really have a deep understanding of elementary mathematics. They have to have really good number sense. They have to have a really profound understanding of how to dissect a text. They have to be able to think and communicate about their thinking. And so it isn't hard at all to show teachers that fact and to show them based on the test, the I-STEP test, which is the Indiana version of this. They see very clearly that if their kids could think and communicate better, they would be better at that test. So we have not had that barrier. The teachers are eager to try these things out. The difficulty comes in sort of the training and untraining habits, things like maintaining very locked down control over what's going on in the classroom and working with them to loosen that up a bit, and that's a process. So we've been working on how do you get going with it? How do you get productive talk to happen in the classroom where it's not the teacher doing the talking? How do you get the kids to be allowed to talk and think and express themselves? So we have been working with different strategies for that. But the game that you play, the finite games, the counting or adding to 20 or up 30 or whatever, those games, for example, are really hit a lot of the standards starting in kindergarten all the way through middle school, for sure, that they have to teach anyway. So showing little standard activities from the math circle community that will do a great job of meeting what they need to do anyway is really possible.
I have to ask you this.
Yes?
I have not found that people understand that the tests teach, understand, well, maybe the New York tests don't, I don't know.
I don't know about that.
Are there any dramatic ways to show people?
Well, it's just, we talk about I don't want to get into too much detail, but there are 3 stages that the kids are supposed to be going through in learning any computational skill, and if you look at the standards, you can see it, although it's not explicit. So I train them to see it. First, they're supposed to have a concrete understanding of how multiplication can manifest itself in the real world in many different ways. Second, they're supposed to get clever and develop their own strategies for figuring out how to multiply in different scenarios, but make up their own ideas for how to do that without knowing algorithms. And then the third stage is to memorize algorithms and get the fluency. And we talk about the importance of that middle stage and how we can see it in the National Core Standards and how to get that to actually happen. The other thing is that you were talking about gifted programs getting shrunk. I don't see that in Indiana either, at least not in these districts. In the South Bend schools, there's a magnet school that has its own curriculum separate from everybody else's, and they put a tremendous amount of effort into those students. It's true that there are students at the other schools that do get left out if they didn't make it into that school who are at the higher end, so I have seen that there. Then the other school has a mandate. Actually, they have no pressure at all to, even though they're failing just as much, they have a lot less pressure to get everyone to pass. Their main pressure is growth model, and so they're actually focusing their efforts and their money on the kids at the high end because they can get more bang for their buck by letting a kid grow who's already ready to go than for the other kids. So in that district, it's actually the reverse problem. They're sort of ignoring the rest of the kids. However, because they're doing that at every school and every grade level, by introducing techniques that work really well for the upper kids, it brings the other kids up too. So
I was going to offer an explanation why the Plano School District is so supportive of this program. Plano is a city of 350,000. Used to south, it's high tech. There is a heavy Chinese and Indian population, and a lot of pressure from these parents to do something more for the kids. And they have tried many programs along the years, enrichment, connected math, and other ones. And apparently this works a lot better and could be defined and continued and taken to a different value, a different level. And they are willing to continue to invest despite the cuts that finally hit also the state of Texas. They are willing to not make any reduction. Moreover, to start new schools in this program. So this is one possible explanation how the district supports.
Well, we have no contacts with districts. Anytime we try to reach to districts and talk to districts, they are not interested. So in our case, we have individual teachers who might be interested or just parents who might be interested, but the system is not supported at all. Maybe we can steal Tito and change it in our area.
Now, I've done much more in your but this is work that cuts across all the goals of all the institutions I work with. I'm always sailing sideways. What about you?
Well, of course, my experience is very, very limited. As I mentioned, the charter school, because I've done, previous volunteer work, so the leader of that school really wanted something like this, and their teacher, is not a professional trained, or the credential is English, so he was learning from the textbook as he was teaching. So that situation opened the opportunity for this program. But so far, there are two other schools. One is a private school. Well, two are private schools, very high-end, expensive private schools. Their principals have contacted me wanting something like that in their school. But the teachers, I thought, were lukewarm, to say the least or the most, or whichever way you go. They felt a little bit threatened by at least the concept of the math circle.
What level teachers? Who teach that? What
The charter school I'm running is middle school, and that's a happy case. The other two, the principals, the administrators, very open-minded. They wanted some program like this for their students. It's a K through 6, and the other is K through 12. So one is a larger.
I find in general, people talk about how and it's true, elementary school teachers don't see themselves as math teachers, they see themselves as reading teachers. And they do math by default. This is fairly typical. And so you would think they're more likely to be threatened, but there's something else that you'll find, especially in elementary school. Elementary school is a different culture from high school. It has a different origin. Our high schools, if you look at, not modern ones, but the traditional high school, if you look at it, it looks like a university building. Towers, ivy. And the university buildings originally look like monasteries because the origin of the university is training for the clergy. And so it's a very old medieval tradition that has come down to the high school. Elementary school is a much more recent invention. It's something that comes from the Industrial Revolution, when everybody had to learn suddenly to read. And Maria Montessori, Thomas Dewey, those people are much more recent. This is much less tradition. And so in general, elementary teachers, and this is not an abstraction, I find this, are much more open to making connections from hither and yon, are much more open to try something new, and will go into it very seriously. So once you crack that resistance, which comes from ignorance, if you go into an elementary school, you have the world open to you. High school's much harder, much more ossified.
I think that's very true as
Yeah.
well. And I'm mostly working with elementary and a little bit middle schools. High school, I think you're right, it's much more challenging there.
It would come from your house.
Yeah,
Tell
I was
us
just,
who you are.
I'm Ed Kettleman from the University of Nevada in Reno. And I was just, you mentioned the ICTM.
shape.
school districts directly for professional development and from MSP grants, Mass Science Partnership grants with universities and school districts and other partners.
Who gets
We're a part of the partnership.
Who gets the MSP grant?
The university usually does,
And so you
and then
go,
I work in our organization partners with them, which partners with the school district as part of that partnership grant. And then we do joint programs at the university in the summers, and then we follow up in
We have support from two math research institutes. We are very lucky in our area. We have two of them. MSRI supports our Circle for Kids, and AIM, American Institute of Mathematics, supports the program for teachers. And these are the only two sources of support that we get.
well, but having been in that world, it's important to know that they are not deep pockets. They themselves get money to support math circles from individuals or foundations. And that's a whole other side of it. But the upside of that, I think, is that they have people, jobs to do that.
There's a lot of money in professional development. A lot. Every district has to spend some money on professional development. And they don't usually have people who do that.
Well, my program is just jump-started by the SEED grant from David's group, and for now, it's just my own volunteer work, so we're kind of putting my earnings from full-time job into there, as long as my husband is prepared to cook, and then he makes money to support
Is he
me,
good?
so I can do other volunteer work, but with our work is also very supportive. I was able to, justify 4 hours a week to go do that volunteer work, and also I help them, raise fund for that charter school, like a backpack week. We helped them with 2,000 backpacks and go back to school events. So that's one thing I'm also interested in learning coming here today. So how to sustain that type of program.
You just told us two very important things, I think. One is how a little bit of money can support volunteers to do what they want to do. I mean, that's a very important thing. I find that in my work, that people want to do these things. If you create the platform, sometimes they will come. And they're looking for a platform to work on. And the other thing is, have you told David how successful this seed money has been? That's really important to know.
Today's like my midterm exam, I'm just telling you.
What I mean is not just, I don't know if you're trying to stop, what I mean is that it's very important for us to advertise our successes and our achievements. Because people want to invest, people who have fun want to invest in something which is successful, which is proven. They want to invest on the edge, but they want the edge to be, their investment to be.
I do want to acknowledge another part of the support. Like, I have friends in professional, engineers and software developers and physicists and teaching in universities. And so I'm just, during Christmas party, I say, hey, you have to come talk to my group, and we'll take you out dinner or go to a movie. And so I've been able to draw upon that pool of personal friendship to do that. But
We had a comment. Tell us who you are, so.
I'm Phil Yaskin from Texas A&M. I think there are two aspects of Math Circles you have to mention. Number one, I run a summer camp, and that is sort of in the realm of Math Circles. It's covered at the Math Circle organization. So summer camp runs 2 weeks, and unfortunately I don't have something going on all year long. I sort of would like to, but I don't at the present time. But they get an immersion of 2 weeks of heavy math activities, and faculty donate time. We're asking about funding. And the students do pay a tuition. This year we're going to be up to $80 for 2 weeks, which parents consider trivially cheap for a 2-week, 4 hours a day program. And then the other aspect is there have been math clubs Tatiana is saying, she had second and third math circle. So the question is, there were clubs before them. Why is it different? And my vision is most of the math clubs are oriented to competitions, training you for math counts, training you for this competition or another. Whereas the math circles are more open-ended activities, problem solving, more thought-provoking type activities. But I don't know if that's, but I do see we have a session here on math clubs. And math clubs can evolve into the more open-ended type activities and not just aimed at taking a test.
Yeah, there are various camps organized in the summer, especially. I happen to run one of them called Awesome Math, and I have information here. And all these things tie together: the Run Math Circus, the summer camps, all kinds of enrichment activities. We have to charge tuition. It's much more expensive than.
Is yours a residence?
It's a
or
residential
commuter?
camp for 3 weeks.
So they live there?
They live there, yes.
Yes, mine's commuter, and that's a major difference.
Let me interrupt a minute.
Yeah.
I was going to draw a distinction. Summer programs convene for a specific period of time. That's how I would separate them from math circles. On the other hand, what I think you're pointing out is that they have a lot of the same forms, a lot of the same considerations.
Activity.
A lot of mental activities, a lot of what we've been talking about apply to when you work in the summer. I'm running summer, I don't know if you call them camps or circles or what, but activities in New York, which are extensions of what we're doing in the winter, the rest of the year. The other thing is, I would use math teams for the term that I is competition activity. And that's another whole aspect of this. Many math circles are organized around a competition. Some are, and then others are not. And I think that's an individual choice to make. The point that I think that the math circle has more than most is some mathematically specific leadership. It's not just people who are math wannabes, who like math. Oh, this is great. But there's people there also with knowledge, who will shape the knowledge for the others. I don't think it has to be a mathematician in the sense of somebody who makes his living proving ignorance. But it has to be somebody who knows more than the people who are there. And that's the distinction I would draw. I hear nods. Yeah, another comment from the audience. Please tell us who you are.
I'm Maria Lukova. I'm from North Carolina. I run some math clubs there. And some of you probably met me online in various places. Yeah, I just emailed you 2 hours ago and so on. So anyway, I wanted to make a point about another distinction here between, I guess, activities that are oriented at people who love mathematics and probably will be mathematicians, and then mathematics for people who, for kids who are not necessarily going into mathematics. So I think both types of kids need enrichment, but the second type is not typically very much into problem solving as such. So, I mean, when I use the word math, the term math club, I typically talk about projects and art and something that's for poets, which may be run by professionals, people who do it really well, but it's something for a much broader audience, basically. Does that matter?
Okay.
Does it make sense for anyone?
I'll be bold and say it doesn't make sense for me for the following reason. When I look at a kid, I refuse to believe this one is going to be a mathematician, this one is going to be
Things the next
or this
year.
one is going to
I
be
don't mean in the future.
Right,
just
well,
in
I'm
the
making a
next
point.
year.
My point is that I want to deliver something mathematical to each of those kids. And so that business, the thing about math for poets, I generally don't concern myself with, unless it's a way of getting them in the door and then doing something, the next thing with them, which is really mathematics. So I don't know if I'm actually disagreeing with you. I'm just saying that the role of the math for poets aspect, I think we all know what we're talking about, you know, coloring and tessellations, but not doing any group theory, that kind of thing.
What's wrong with that?
The
I am talking about humanistic mathematics.
yeah, well, I think it has to progress to something which is mathematical. It may not look like problem solving in the classic case that we know and love, but for those students it is, in the sense that it's a well-defined problem. It's not necessarily a part of real life. It's not based on words. It's not based on rhetoric. It's based on logic. And if we can get them in the door that way, that's fine with me.
Can I add to say?
Yeah.
I do think everybody, every kid, at least I want to believe, they have the innate ability to tackle problem solving. Maybe not obviously in a traditional mathematical way, but problem solving is innate to human nature. So it shouldn't look at a kid's performance in their school, either math or whatever other subject. I think giving them opportunity and ignite that natural curiosity for problem solving and searching for answers for themselves, that is kind of a core of this kind of math enrichment or whatever you call it, the humanistic math program. I just felt in the school setting, this is not at least reinforced or introduced as much as we would like to see. And for those math arts and crafts, I kind of call them awareness programs, which is completely fine. I think that no matter in what way, shape, or form students are exposed to math, it can only be good.
My name is Joanne Kimball Sherman. I'm a first grade teacher. I'm one of those elementary teachers from a brand new math circle in Melrose, Massachusetts. And my math circle is from first to fourth grade, but I'm hearing most of the math circles up there are from fourth, fifth, middle school, and high school. Is there a reason why there aren't lower elementary? Okay, go right ahead.
Elementary school is too hard for me.
It's a lower elementary, I absolutely agree.
That's the main reason we don't have more elementary school math circles in our area, is because it's too hard for those of us who run math circles to do that.
But
But you're
actually,
in Massachusetts, you should get to know the capital.
The Kaplans, and the woman who started my math circle is friends, yes.
I run math circles for kids ages 4 and up, sometimes 3. I run them with parents for younger kids. Somebody already mentioned that they started this math circle and they noticed that the kids are getting younger and younger. And now this is a very widespread phenomenon. This happens to all circles. All of a sudden you see younger and younger kids coming through. And because of and people realize that there is a necessity of studying math circles for elementary kids. Because of that, Berkeley started a circle for elementary math kids. And now they started, the same people started another circle for elementary kids at Stanford. So it is a growing thing. Oh yeah, and there is a book written by a Russian mathematician. He ran a sort of a math circle for his own kids when they were studying with very young age. And he when he was writing that thing, he was also writing his journal about his experience just for himself. And then eventually somebody read that journal and thought that it was a fascinating book, and they published it in Russian. Now it is ready to be published in English. Paul Zeitz was editing translator of that book, and it's going to be published by AMS in a special series of books called MSRI Math Circle Library. And this book is by Zvonkin, and this what's the official name nowadays?
I don't know anymore.
It's something like
The Russian name is Young Kids in Mathematics.
yeah, it's mathematics for young kids. I
Yeah,
believe
something
they will
like
be the official name.
But Zvonkin is
Yeah.
and he writes very cogently about what Josh and I don't know how to do.
the elementary school level students. What specifically are you talking about? I'm sure I can relate on whatever your answer is. I'm just curious what specifically you mean.
So, I mean, to me, what makes a good math circle activity is something that has accessibility to everybody and then lots of layers of depth that you can dig into. And it's really easy for me to invent things like that once kids have a certain amount of background. But when I try to construct things like that for younger kids, it's so hard to have those depths without assuming some skills that they just don't have yet. And so finding that kind of rich enough activity that all the kids can be engaged in. I have a very small library of those, relatively speaking.
And let me clarify. My feeling is that it's not wrong, it's not impossible, it's just something that I don't know how to do. I can do it. I've had math circles down to 3rd grade. Once they can know the background that Josh is talking about, I know how to exploit, as long as it includes some semblance of multiplication. I'll take multiplication numbers between 1 and 5 is enough. But I have the sense, but I haven't explored enough. This is, my own confessional, that there's more to this. Because mathematics, after all, is not about multiplication or addition or anything particular like that. It's about making, if you want to push me to the wall, it's about making connections among statements. That's what mathematics is about. And the statements could be anything. And kids, I'm going to go out on a limb here because I'm not a developmental psychologist, but very early kids have ways of making connections among statements, making generalizations, making special cases, even making inferences, which is like the gold standard of mathematics. Mathematics is about implication. And that's what Bertrand Russell says. And this develops quite early. And I would be very more than curious, eager to know how people do this, but it's not something I know how to do. And that, I think, answers your question a little bit from the prior.
I think I have a little more to say too, because there's the classroom management side of working with little kids also, but you could solve that by having the parents involved, for one example. There's lots of ways around that. But I think also just in terms of the collection of math circle people that we have, the kinds of skills it takes to be the mathematician who can run a math circle and the kinds of skills it takes to work with the little kids are different, and there just aren't that many people in whom they overlap very much.
I am working to develop these skills. I have 2 graduate students at Quran, they're PhD and math graduate students, and I can get them to work with middle school kids, especially the upper level, where they recognize that it's already emerging, it's purely mathematical thinking. I have trouble getting them to relate to the kids I can relate to, and I would have the same trouble relating to first graders. I have empathy for that. There's people who want to talk,
Yeah, I'm actually Alina. I run a math circle for elementary kids in East Lansing, Michigan. And I'm just identifying here, I think there is a contingent of people who are really interested in thinking about elementary math circles, and I'm sort of the mathematician being stretched by working with really young kids, but I think there's a variety here. So I'd just like to suggest if there's a way within the program to find just a free time when those who have that interest could gather and talk more about this. I would love to have that chance. So.
David, can we do that?
Or, I'm just thinking, when we're all done
Not to
this
put you on
evening
the
or
spot.
something, some other time. I just wanted to mention it now so that those who are interested maybe can touch base.
Anybody wants to sit
Yeah,
at
we have-
sit at Ashley's table for dinner.
We have a banquet.
On Saturday.
That'd be great. I would love that.
Want to say something?
I'm Dan Ullman from George Washington University. There are several comments that I thought played together in an interesting way. Amanda said there's lots of money out there for professional development, and she's right. And Tatiana said you have to convince the teachers that this is just for them, not for their students. I think Tatiana is right too. But these two ideas don't go together because nowadays every professional development program has to demonstrate that the teacher's students are improving because of the program. This is sort of more of No Child Left Behind. And in some ways, I know we're reaching the end of our time, this feels like a summary to me. One of the things about math circles is that it requires a willingness to look at the long-term picture and not the test that's coming up at the end of the year. Probably all of us would be better off training our kids in addition problems. All we're going to see at the end of the year view, then, and the longer view means don't test the students that year and put the high stakes test on the teachers based on what the kids can do that year, and treat the kids as if they have long lives ahead of them, and the way they learn to think about things.
Little do they know.
So anyway.
I just want to say.
Just tell me you are.
I think I'm Mary O'Keefe from Albany Area Math Circle, and I just want to say, I think we have to think a little bit outside the box. It's true, a classroom full of elementary school kids doing Math Circle can be chaos. But what my daughter Allison and I started out doing, 15 years ago, was just ask the teacher, give us 4 kids who are driving you crazy, and we'll take them to a little room down the hall, and all we'll promise to do is keep them out of your hair for an hour. And this was my daughter, and the other thing I want to emphasize, so my daughter was 9 at the time, and she was doing it and helping me lead these little groups. I think that just as high school students, we're going to hear from some later this weekend, can run circles for younger students. I think middle schoolers can be really wonderful working with elementary school kids. We don't have to think about getting the grad students so they can connect with the kids. The middle schoolers will learn so much from working with younger kids, and we need to think outside the box. The same thing, not just schools. There's like a free lunch in the park in the summer. That's a wonderful place to, take those polygons and put them out on a blanket. A community center that's in a little bar and grill in the inner city. The YWCA, Girls